The local electronics store sold 4,500 TVs last year, 1,000 brand A TVs, 1,500 brand B TVs, and 2,000 brand C TVs. The estimated probability that a brand A, brand B, and brand C TV will last 30,000 hours is 0.9, 0.85, and 0.8 respectively. If a TV sold from the store is randomly selected and is working 30,000 hours later, what is the probability that it was a brand A TV? Okay, so let's go ahead and set up our tree diagram. We've got 3 TVs to choose from to begin with. We've got brand A, B, and C. Now to find these initial probabilities of if we randomly choose a TV out of these 4,500, so they're going to be out of 4,500, the probability that it was a brand A TV is there were 1,000 sold out of 4,500. So if you reduce 1,000 out of divided by 4,500, you get 0.2 repeating, which as a fraction is 2/9. The probability that it's a brand B TV is 1,500 out of 4,500, which that reduces to, let's see, 1,500 divided by 4,500 is 0.3 repeating forever, which is 1/3. And the probability of it being a C TV is 2,000 out of 4,500. So I'm going to edit this. What's 2,000 out of 4,500? That's 0.4 repeating forever, which is 4/9. Those are all my first branch probabilities. Now, we are interested in whether the TV is working or not working after that 30,000 hour mark. So I'm going to label my next levels as W or W complement. So it's either working or it's not working. Okay, the only ones that I'm going to continue on to find their intersection and the end are all the ones that end in W, because remember, because if you're looking ahead, that's what we're interested in, is that if it's working. So those are the ones that I'm going to particularly focus on. The probability that it is in fact working, given that it came from, or that it was a brand A, is a 0.9. And I could do the complement for not working, but that's going to be irrelevant for our question, it appears. So I'm going to skip down. The probability that it's working given that it's a brand B is 0.85. And the probability that it's working given that it's a brand C is 0.8. So I'm going to find my intersections. The probability of A, that it's an ATV and it's working, is 2/9 times 0.9. So let's see, what is 2 divided by 9 times 0.9? That's 0.2. The probability that it's a B television and working is 1/3 times 0.85. So I'm going to do 1 divided by 3 times 0.85. And that doesn't come out nice, so I'm going to go ahead and I'm going to see, does it look better as a fraction. I'm just going to call that 17 out of 60, just to be totally accurate. And then the probability that it's a brand C and it's working is 4/9 times 0.8. So let's see, what's 4/9 times 0.8. And then I'm going to see, I think this one might come out better. No, okay, it's 16 out of 45. So if we want to know The question here is, what's the probability that we have a brand A TV, so A, given that we know that it's working 30,000 hours later? So again, we're trying to find a leftmost branch given a rightmost branch. So we're going to use our Bayes theorem, which means take the particular branch in question. So take this top branch here. That's the one we want to know specifically. So that intersection on the top, 0.2, divided by all of the branches that ended in W, all of these added up. So on the bottom, we're going to take 0.2 plus 17 out of 60 plus 16 out of 45. So let's see, we got 0.2 on the top. Now what do we get if we add together 0.2 plus, and then 17 divided by 60 plus 16 divided by 45. Okay, so I'm going to turn that into a fraction to keep it very, very not rounded. So 151 out of 180 is what that comes out as. So now I want to divide. What do I get when I take 0.2 and divide it by, and since I'm dividing by a fraction, I'm going to put it in parentheses. Divide that by 151 over 180. And it looks like we get 0.2384, or about 23.8%. And you'll just have to look at how they want you to enter that answer. Follow the directions that you're given. If they say to leave it as a decimal, or if they say to change it to a percentage, they give you a specific rounding information. They could ask you for a fraction, and we could give it back as 36 out of 151 in that scenario. So, any of these could be fine ways to enter your answer, and you just have to do whatever you're specifically asked for by the program. What is the probability that it was not a brand A TV? Okay, well, don't work hard on this one because we know how to use complements. So we just found that the probability that it was a brand A TV, given that it was working. So all we need to do is do 1 minus the probability that we already found to find the probability that it was not a brand A TV, the probability that it was one of the other two. So let's do 1 minus, the easiest way to do this is probably going to be to use the fraction to be the most accurate. So 1 minus 36 over 151, 1 minus, and then in parentheses, 36 divided by 151, close that up. So that's approximately 0.7616, or about 76.2%, or as a fraction, we could say 115 out of 151. So again, any of these would be acceptable. You just have to pay very close attention to how they ask for the answer.